We're now going to talk about the fact that we can now fully draw an exponential graph and find all the axial intercepts. So in the previous section, we graphed exponential functions, but often we could not find the x-axis intercept. Now that we have defined logarithms, this can be done. So we're going to sketch this before us, giving the equation of the asymptote and the axis intercepts. So let's see how we go with it. First thing that I'm going to do is put in where my asymptote is going to occur. And as you can see, I'm shifting down 4. So that means it's going to be right here. It's going to be y is equal to -4. Also looking here, you can see that I have no reflections taking place, which is really convenient for me. I'm not reflecting in the x or the y. So the next thing that I'd want to do here is just find what my y-intercept is and what my x-intercept is. I know that I find the y-intercept by letting x be equal to 0. So that means I'm going to get y is equal to 2 times 10 to the 0 minus 4, which is going to be y is equal to 2 times 1 minus 4, which is going to be y is equal to 2 minus 4, which is y is equal to -2. So that means it's going to be about here. Then I'm also going to find the x-intercept, and I'm going to find the x-intercept by letting y be equal to 0. So that means I'm going to get 0 is equal to 2 times 10 to the raised to the x minus 4. And then once I'm here, I can do a bit of rearranging. I can bring that 4 over. 2 times 10 to the x. I can divide both sides by 2. And now I can get this stage right here. And now what you have to recognize is that I can't get this into a form where I have the same base and then equate the indices. So what are you left with doing? Well, you can easily just say, well, x is going to be equal to log of a base 10 of 2. And just like that, you've got what your intercept is going to be. So that means our graph is going to look something like this. Let me get rid of that. It's going to look something like that. This point here is going to be 0, -2. That's not a negative. Let me try that again. Oh, go away. 0, -2. And then this point right here is going to be log 10, 2, 0. And there we go. Make sure you can also do this on the CAS. So for instance, if I went menu 3, 1 to get this up, and then I went, all right, I'm trying to solve 2 times 10 raised to the x minus 4 equals 0, and I'm trying to find the x value of it, and I hit enter. Now it's going to give me it in that form. So remember, that's the change of base rule, and you can kind of see that in action there. The 2's up the top, 10's down the bottom. We could also figure out what the approximate value is. So it's going to be something like that. So this probably should be a bit steeper, but that's all right. And also remember that you can graph this like this as well. Oh, wrong button. Control at doc, at graph, and I might cheat a little bit. I might just steal this. Remember, this is like a computer. Control C. Then I can come here, and then I can go Control V. Then I can hit enter, and there it is. So it's a bit steeper than I did it. And then you could also do it like this. Menu, analyze. I want to find the 0 from there to there. There it is. Is that the same as what we got here? Yes, it is. Could we also find the y-intercept? Yes, we can. Menu, trace, graph trace. It's when x is equal to 0. Type in 0, hit enter. 0, -2. There it is. So if I wanted to be a bit more precise with this, maybe I would come here and I would do it a bit more like that. And that's even still, just so it has a bit of a more curve to it. It's not really going to make a big difference. Only if you're like kind of radically off would marks be taken off. The first way was fine. Perfect. Hopefully that makes sense on how to approach this question. There is our graph. Make sure it's approaching the asymptote correctly, and you got all of those things on it. All right, hopefully you found this helpful.